We're now going to solve systems by substitution here. So instead of having two equations, now we have three. And we can do this. So instead of an ordered pair, we're going to have an ordered triple, which is kind of neat. And if you think about it, the xy plane is just up and down, left and right. So we can think about it, the xyz is now we're in a three-dimensional system instead of a two-dimensional, which is like we're in the real world in space. So cool. So now let's go for it. This third equation here, you guys, right here, is a dead giveaway. I can immediately solve for z, which is beautiful. I love that. Z is equal to -3. So I write it in there so I remember that I have my z value and everything's hunky-dory. So this equation is done. We're done with this one. We're so done. But now I can substitute in -3 for z and get y. So 3y plus z equals -15. So I'm putting in a -3 for z. So 3y minus 3 equals -15. 3y is equal to -12. Y is equal to -4. Boom! I'm done with that one. This guy I'm so done with. And then last but not least is now I can substitute both of those values in and solve for x in the first one. X plus y minus 4z equals 9. So x plus a -4 minus 4 times a -3 is equal to 9. So x take away 4 plus 12 is equal to 9. Negative times negative is positive. X plus 8 is equal to 9. X is equal to 1. Boom. Done. So that's substitution. If you can look and see where you can substitute in, you're going to be awesome. For this one, we're going to solve the system by addition. So what we're going to do is, all of these you have to just gain experience, be a little bit clever about stuff. So if we think about it, we're going to have to use these two equations and these two equations to help us cancel one variable out in both of those, and then again a system of two equations and two unknowns. So let's look at it and try not to panic. So 2x minus 2y plus 8z is equal to 4. And x plus 3y plus z is equal to 15. Good? And I want to get rid of the z's. So I'm going to multiply this second equation here by -8 so I can get rid of the z guy. So I'll get 2x minus 2y plus 8z is equal to 4. And -8x minus 24y minus 8z is equal to -120. So when I add down, I will now get -6x minus 26y. The z's add out, -116. So now I have these guys. Next, I'm going to look at these two. X plus 3y plus z is equal to 15. 5y minus z is equal to 19. If I do that, the z's will automatically add out. And I will get x plus 8y is equal to 34. Now, what I'm going to do is I'm now going to use these two equations to solve for x and y, and then I can go back and solve for z. These are quite lengthy problems, but you can do it. So here we go. Now here's the deal. See this one that's in blue? There's a common factor of 2 in every single one. So I am just going to divide everything out by 2. So I have negative 3x minus 13y equals a negative 58. That kind of cuts the problem down a little bit more. So now let's put both of these in black. Negative 3x minus 13y equals a negative 58, and x plus 8y equals 34. Now let's multiply this bottom equation by 3. So negative 3x minus 13y equals a negative 58. 3x plus 24y is equal to 102. So I will get 11y is equal to 44. Yay! Y equals 4. Thank goodness. So up here, I'm just going to write my ordered triple. 4 for y. Good. Now I can immediately, now that I know y, I can get x, and then I also can get z just by using this third equation here. Let's get those values. So let's use this red one right here to get x. So x plus 8y equals 34. So x plus 8 times 4 equals 34. X plus 32 equals 34. X equals 2. So I write the 2. Yay. Now let's use again this third equation to get z. So let's do it in blue. 5y minus z is equal to 19. So I am going to put 4 in for y. So 5 times 4 minus z equals 19. 20 minus z equals 19. Z has to equal 1, right? 20 minus 1 is 19. And those are my ordered triples. Next, let's solve this system. And it doesn't state which way to solve it. So I'm going to do it the exact same way as we did the other one. So here we go. We're going to gather these guys with the blue. Now automatically these y's can cancel out. So I'll just cancel them out. So I get 5x plus 3z is equal to 13. So I'll put a star next to that one because we're going to need it. Now let's do the next one in red. So we're going to pair these guys together. So 3x take away y plus z is equal to 7. X take away 2y minus z is equal to 0. Yes, if I add down, the z's will cancel, but it won't help me because I really just want x and z. So I need to cancel the same variable out that I just did. So we need to cancel the y out. So I'm going to multiply the top equation by a negative 2. So I'm going to get negative 6x plus 2y minus 2z is equal to a negative 14. And x minus 2y minus z is equal to 0. Now I can add out the y's. Yay! So I get a negative 5x minus 3z is equal to a negative 14. Now, beautiful. This is so awesome because we're going to use the two starred equations to get rid of a variable here. So let's do it in black because it's got to be dramatic. So when we add down, one side will cancel and the other side gets negative 1. So what does that mean? That means that this system has no solution. So the solution to the system, there is no solution. The system is inconsistent. Okay, let's solve this next system. Again, we're going to do it the same way. Except I'm going to kind of look and see if I can cancel anything out fairly easily. And I'm going to go for the x's. Now, you can go for the y's or the z's, but for the first two, I'm going to go for the x's. Okie dokie. So I'm going to multiply the second equation by a -1. And I'm just going to add down 3y, take away z, is equal to a -5. What do I do with this? I star it, of course. Then we'll do the bottom two, the red. So x take away 2y plus 3z is equal to 6. Perfect. I want to cancel the x's, so I'm going to multiply the top equation by a -2. And I'm just trying to be super careful. -2x plus 4y minus 6z is equal to a -12. And let's write the second equation here, which is 2x minus y plus 5z equals 7. The x's will cancel. Yay! So I'm left with 3y minus z is equal to a -5. I'll star this and bring them on over in black. 3y minus z is equal to a -5. 3y minus z is equal to -5. So basically, you're ending up with the system where it has the same, if you will, quote-unquote line. So this system is dependent because when I go and I multiply this second equation through by, let's say, a -1 here, because that'll be easier, I will get 3y minus z is equal to -5. -3y plus z is equal to 5. 0 equals 0. Bam! I end up with a true statement. So what do I say for this system? There's infinitely many solutions. And we're not going to write out what a specific solution is in this case. We're just going to say there's infinitely many of them. Next. For this next system, there's a whole bunch of fractions, but don't panic. Let's just clear the fractions in each equation and then solve from there. So here we go. I'm going to multiply by the common denominator of each equation. The first equation has a common denominator of 4. So I'm going to multiply everything through in this first equation by 4. So I'll get -2x plus 2y minus z is equal to a -24. Now this is like a cute little, the equation has become tame. The next one we have 4, 3, and 2, so I'm going to multiply through by 12. So here we go. So 12, 12, 12, and 12. So we're going to get 3x plus 4y minus 6z is equal to a -12. Last but not least, I'm going to multiply through in this third equation by 6. So I'll get x, take away 2y, plus 2z is equal to 24. So, what am I going to do? Well, for this one, unlike the previous ones, I'm going to use these two equations in blue. And then I'll probably take these two in red. So let's do the blue first. You're like, why? Well, if I look at it, the y's are going to cancel automatically right away. So for those two equations, so it's just wicked easy to use them. So write down the blue guys. I get negative 2x plus 2y minus z is equal to negative 24. X minus 2y plus 2z is equal to 24. So the y's wamba, so I get negative x plus z is equal to 0. Star it. Star it. Okay, next, let's do the red guys. And we get negative 2x plus 2y minus z equals negative 24. And 3x plus 4y minus 6z is equal to a negative 12. So if I multiply the top equation by negative 2, seems like that's all we're doing, right? We always do negative 2. And then I'm going to be able to get my y's to cancel out. So I'm going to go positive 4x minus 4y plus 2z is equal to 48, and 3x plus 4y minus 6z is equal to negative 12. Wamba, 7x minus 4z is equal to 36. So now I star him. Yippee-i-o-ki-yay. So now we use the two stars, come together, get one thing. Yay! Black. Negative x plus z is equal to 0. And 7x minus 4z is equal to 36. Now, let us multiply the top equation by 7. So a negative 7x plus 7z equals 0. And 7x minus 4z is equal to 36. So 3z equals 36. Z equals 12. So we have the z value in our ordered triple, XYZ. Now, well, if we use this guy, we can get x really easily because I'm going to look at negative x plus z has to equal 0. Z is 12. If I bring the 12 over to the other side, I get negative x equals negative 12, x equals 12. Or you can see as if I bring this x over to the other side, x equals z. So bam-o, x is 12. And I have my x coordinate of my ordered triple. Last but not least, we have to get y. So we can get y from the original, which is technically what we should do, but I'm going to avoid that and just choose one of these three equations without the fractions to get y. So let's just choose the first one, and I'm going to kind of squeeze it in. Negative 2 times 12 plus 2y minus 12 is equal to a negative 24. Now let's evaluate. Negative 24 plus 2y minus 12 equals negative 24. So if I I'm going to combine like terms, so I get 2y minus 36 equals negative 24. 2y is equal to 12. Y equals 6. So 6 is my value for y. Now you can do the assignment associated with this lesson. Stay strong and go for it.